past decade, astronomers using sensitive radio and infrared techniques have begun to probe the wombs of stellar formation, dark molecular clouds. In the course of these studies, we've managed to achieve a much greater sense of how star formation is triggered and the details of the earliest stages of stellar evolution. More work remains to be done. For example, how do clouds begin to fragment? What role does the magnetic field play during the collapse of protogalactic clouds? How does the early evolution of a star really proceed? When is a disk formed? When does the stellar wind first turn on? Over the past decade, astronomers have been able to look at those objects which are located near the surfaces of dark clouds, and those objects which therefore are not heavily obscured by interstellar dust. These would include the early type Herbig emission stars, stars of on the order of 3 to 10 solar masses, the T-Tauri stars, and finally the so-called Herbig-Auro objects. Infrared observations of these objects are of major importance because at these wavelengths we can do two things. First, we can probe through the dense, dark material because it's more transparent at infrared wavelengths. Secondly, we can observe several types of objects by virtue of their strong infrared radiation. For example, astronomers have discovered objects which appear to be stars surrounded by envelopes of gas and dust. In some cases, we believe these envelopes to be disk-like in form. Perhaps, in fact, we've observed the formation of a protoplanetary disk, the type of disk which gave birth to the planets in our own solar system.
Within the fathomless depths of space, stars are continually forming. We now know to look to the vast clouds of interstellar dust and gases to find their birthplaces. Perhaps in our own galaxy, or among the countless others in the universe, there are stars orbited by planets. And since all things in the universe, living and inert, are formed from the same basic chemical elements, perhaps some of these planets may be favorable for the evolution of intelligent life. Time and space are our gateways to understanding.